Hi, the section 4K, the continuous varying annuities. We continue to the case 3. So remember that in the case 2, that we calculate the present value of the continuously varying annuity at the rate of y is equal to ft. But the interest rate was constant, effective interest rate was I. Here, that we generalize a little more, and we assume that the force of interest at time t is the delta sub t. So now that we want to calculate the present value of the small amount of payment at time t, the between time t and time t plus delta t. So remember that when the force of interest is given, when we want to discount the value from time t to 0, we have to multiply the e to the power the negative 0 to t delta sub r, the dr, times the amount. Amount is f of t delta t. So to calculate the entire value from time 0 to t, I would say the 0 is here, so t is suppose here. Then what's the the present value of the entire amount here? So that is the integral from I would say the 0 to n, so amount for 0 to n. And we have to integrate this amount from the 0 to n. So that is the present value of this entire payment. So the present value is equal to integral 0 to n, this quantity, so e to the power negative 0 to t, the delta r dr, f of t dt. So by the definition of integral, the present value can be written in this way. So accumulated value, how about the accumulated value at time n? So basically we have to evaluate the time value of money. So amount is at time t, basically, that we have to evaluate at time n. So the accumulated value have to accumulate the interest from t to n. So accumulated value of the shadowed quantity is equal to the e to the power integral t to n, the delta r dr, times this amount ft, the delta t. So the entire accumulated value of the area from 0 to n is equal to integral 0 to n e to the power from t to n, the delta r dr, delta sub r dr, times the f of t times dt. So this accumulated value is of course larger. The present value, basically this quantity is negative, but the accumulated value, this quantity is positive. So accumulated value accumulates n years of interest compared to the present value, so it's larger.